Okay, this session we'll be doing a few questions on exam revision. I won't be covering all the questions because it will take too long and we're running out of time. But I'll be doing questions that I haven't already put on the other lessons. So most of these topics and questions, there are examples on the other lessons that you should have watched. All right, so we'll just start. I'll just pick a few that we haven't revised yet. And the first one I'll do is this one here. Solve the following pair of simultaneous equations using the substitution method. So to use substitution to solve or find the solution of using simultaneous equations, just to recap, the solution means to find the point where these two lines cross over, and that is at that one point. That's where they're simultaneous, where they share the same point. And simultaneous means the same thing, two things happening at the same time. And that is only one point that these two lines share. Now we know these are linear equations because the highest power of my x and y is a positive one. They're not in the form of y equals mx plus c, and that's okay. To use substitution, you have to have either an x equaling everything or at least a y equaling everything. If both equations didn't have x or y the subject, so I can see with this equation here, x is the subject, which means x equals everything, then you would have to rearrange it yourself. But because it's done for me here, because I know x is or equals 9 minus 4y, now I'm going to put brackets around it, and that's very important because when we substitute, you must substitute with brackets. And now I'm going to replace that x with 9 minus 4y because I know x is equal to this. So I'll just change the color, 3, and just to emphasize, this x is now in brackets, 9 minus 4y, and close brackets, plus, should have changed color, plus 2y equals 12. And now we can see what we have achieved. We now have one variable in this whole equation, which is y, and we can solve it. Whereas here we had two unknown variables, and you can't solve an equation with two unknown variables. So we'll just expand the brackets. So 3 times 9, we have 27, take away 12y, plus 2y equals 12. I'll simplify this bit here, minus 12y plus 2y. So 27 will be negative 10y equals 12. And now I'll get rid of my positive 27 by subtracting 27 on this side, and that can go away, and 12 take away 27. So I'll be left with 10y is equal to a negative 15. And now we're just going to divide by negative 10 and divide by negative 10. And I can see that two negatives will make a positive. I do have that's a y there. I do have an improper fraction, but I can simplify this. If I divide 15 by 5, I'll have 3, and 10 divided by 5 is 2. And there's my final answer. And if you wanted to know the point as decimal, that is 1.5. And we have found the y value of this point where the two lines cross over. Now I need to find my x value. So don't turn this into a mixed fraction. We'll leave it in this form when we substitute it into an equation. I'll just rewrite the equation. Okay, so we have found out that y equals 3 over 2 or 1.5. Now we have to find our x value. So far we have found that. You can write 1.5 if you want to. It makes it easier to plot if you had to draw this. Now, to find our x value, substitute. So we'll sub in when y is equal to 1.5 or 3 over 2. So we'll sub it in. It's good to explain the steps you're taking to show proper working out. Now you can substitute this into either equation. It is your choice. Both will give you the same answer. I'll just use the first one because it just looks less complicated, I guess. So x equals 9, take away 4. Now instead of y, I'll just change color to emphasize. Now we always substitute with brackets. Okay, I have 4. I know in between my 4 and y there's a times. Okay, so my bracket will indicate that as well, and 3 over 2. And don't forget there's a times, an invisible times there. So we now have x equals 9 take away. Because there's a times there, I can ignore my brackets now. The negative's there, so I'll simplify my 4 and 2. So 2 divided by 2 is 1. That 4 is sitting on a 1. And 4 divided by 2 is 2. Then I have 2 times 3, which leaves me with 6. And 9 take away 6, I'm left with a 3. And I have found my x value, okay, which is 3. Okay, so the final answer you should have, therefore, we say the solution is, and write your final answer as that point, when x is 3 and y is 1.5. And you can leave it in fraction form as well. Okay, and that's it. So please make sure you write your final statement on what you have found. And don't forget, the solution is just referring to where these two lines cross over and where they are simultaneous. They share one point, and this is the point they share. And we found it without having to draw these two graphs. The next question I'll be doing is this one here. Because, well, I'll do these two. Because so many students do this the hard way, and they expand their numbers and then try and simplify, and it gets into a big mess, and there is a really easy way to do this. So with these two questions, we'll be using the index laws. With the first one, remember, whenever you see a negative power, you have to turn it into positive. And to do that, I know that 4 to the power of negative 3 will end up going on the bottom. And I know that it's sitting on an invisible 1. So, and there's also a 1 on top that's invisible. So I now have it negative, the negative now becomes a positive. So 4 to the power of positive 3 plus, and the same thing, this goes on the bottom, so I have 3 squared. So 4 cubed and 3 squared. And now we can work this out. We have 1 over 4 cubed is 64 plus, and then we have 1 over 9. And using your fraction skills, you get the same denominator and add your fractions. Or you can use a calculator to assist you. But I won't be doing, you can finish that yourself. Now number 2, please don't go 4 to the power of 4 is whatever number, and 4 cubed is this, and then 5 to the power of 5. You end up with this very, very large number, and you can use your index laws on this. Even though we don't have variables, like for example, if my 4 was an x to the power of 4, and on the bottom I have x to the power of 3, and I told you to simplify this, you would know, well, take away 3 x's from the bottom, it's gone. We always take away our smallest amount. And then 4 take away 3 would leave me with 1x, or x to the power of 1. And that would be my answer. So we'll be doing the exact same thing, because the 4s have the same base. I've got a 4 on top and a 4 on the bottom. Same with my 5s and 7. So just cross off your smallest amount and you're done. So 4 4s on top and 3 in the bottom. So I can take away 3, it's gone, or it's really a 1. And 4 take away 3, I'm left with 1 4, or 4 to the power of 1. 5 4s on top and 5 5s on the bottom. So my smallest amount is 4, that's gone, that's a 1. And 5 take away 4, I'm left with 5 to the power of 1. And I have 1 7 on top and 1 on the bottom. Well, that's gone and that's gone. So all I'm left with is 4 times 1 times 1, which is just 4, over 1 times 5 times 1, which is 5. And there is my answer. We'll be now solving the following pairs of simultaneous equations using the elimination method. Before we use substitution, now we will be using elimination, and this method is the trickiest out of the methods, but once you get the hang of it, it's just as easy. So our first step is elimination means to eliminate, get rid of a variable, and we have two options, our x's or our y's. In this case, we don't have a variable where the number is exactly the same, therefore we can never get 0. For example, if I have 2 and 5, there is no way whether I add or subtract that I can get 0. And the same with 3 and 6. To get 0, we have to have the same number. So our next step is we have to make these variables, the numbers in front of them, the same. And it is your choice. I might pick my 3 and 6 because I know I can turn my 3 into a 6. And this is the same idea as if I had a fraction, 1 over 3 plus 1 over 6, and I asked you to get the same denominators, you would simply go 3 times 2, and of course you must do the same thing to the top, and 1 times 2, and it will give you 1 over 6 plus, 2 over 6 plus 1 over 6, and then you add your fraction to get 3 over 6, which is a half. And we're using that same idea. And just remember, if you're wondering to do this, if I just quickly showed you an equation, if I have, pick anything, 2x, so 2 times a number that gives me 10. Okay, I know that 2 times 5 gives me 10. Therefore, I know x will equal 10. But if I divide by 2 and divide by 2, I know x will equal 10. It's a basic equation that we can solve. Now, if I decided to change these numbers and I do it to both sides, so if I said, okay, what if I times this side by 3 and I times this side by 3? Have I changed my equation or will it remain equivalent? Well, let's have a look. Well, 3 times 2 is 6x and 10 times 3 is 30. If I divide by 6 and divide by 6, 30 divided by 6 is 5. And I can see that x still equals 5. And so what we've done here, by multiplying both sides by the same number, we have made an equivalent equation. An equivalent means the same or equal to. Just like fractions. If I have a half and I times the top and bottom by 2, I will have 2 over 4. And we can see that 2 over 4 is the same as a half. They're equivalent fractions. Well, these are equivalent equations as long as you multiply everything by that same number. So let's try that. So I'm going to make my 3 and 6 the same, which means I'm going to times this equation by 2. Now, don't worry about thinking, do I multiply by a -2 or a +2? Just forget about negatives. You multiply by the number only. We deal with negatives and positives or adding and subtracting later. And now when you do this, everything gets a turn to be multiplied by the 2. Everything that is separated by a plus or subtraction. So I can see I've got a 2x here, a 3y, and a 3 here that all have to be multiplied by 2. I don't touch this equation here because I'm going to turn my 3 into a 6. So this is really, we can say equation 1 and equation 2, okay? And you can write a little note here saying we are multiplying equation 1 by 2, but I haven't got enough space. So it's important to show clear working out. So my next equation, I can call this equation 3. I will have minus 2x times 2, well, that is negative 4x, and positive 3y times 2 makes positive 6y, and 3 times 2 is 6. And equation 2 has stayed the same. So 5x take away 6y equals 6. Oh, sorry, it's negative 3. It stays the same. Okay, and now we can finally make our y's disappear or eliminate them. But be careful. What I want you to do now is, see how you got a positive 6? Just do a little bit of working out. We've got a 6 there, that's positive. Here, that 6, what is it? It's a negative 6. So write a negative 6. And we want these to equal 0. What operation do we do? Do we add them or subtract them for them to become 0? This is very important that you make sure you're doing the right thing. If I put subtraction in there, look what happens. 6, if I have, don't know what just happened. Hang on. So you can see that a negative and negative will make a positive. If I subtract these, I'll end up with 6 plus 6, which doesn't give me 0. So what I have to do to achieve 0 is plus these two numbers, the 6, positive 6 and negative 6, and that will give me 0, because a positive and a negative give me a 0, which means I am now going to plus equation 3 and equation 2. I'm going to be adding them, okay? So, and I must make sure I add everything else, okay? Every other number, and be careful with your negatives and positives. Now here I have minus 4 plus a positive 5. Minus 4 plus 5 is 1x, or just x, and I know that 6, a positive 6 plus a negative 6 gives me 0. You don't have to write it, but I'm just going to write it to emphasize we have 0y, which isn't there really. And then we have 6 plus a negative 3. So 6 plus a negative 3 is 6 take away 3, which leaves me with 3. Okay, so I just charged my laptop. And now that is really not there, because 0 times y is just 0, and I'm left with x equals 3. So that was nice and easy for me. And I have found my x value for x. And now all I have to do is substitute this into either equation to find my y value, and I have found the point where these two equations cross over. And so if x is equal to 3, so my next bit of working out, so when x is equal to 3, or we can say sub in when x is 3, I'm going to pick an equation. I'll just pick my, where are they? I'll just pick the second equation. So 5x minus 6y equals -3. So when x is equal to 3, I'm going to substitute it in this equation and find my y value. So I will have 5, instead of 5 times x, I will have 5 times 3, always substitute with brackets, take away 6y equals -3. 5 times 3 is 15, so I'll have 15, take away 6y to give me -3. I'll just write out some. My next step now is to take away 15, 0, take away 15. So I have -6y equals -3, take away 15, that's -18. Divide by -6, divide by -6, and finally 18 divided by 6 is 3, and two negatives make a positive, and I have found my answer. So y also happened to equal 3. And of course your final statement, therefore the solution, and we know the solution is where these two lines are crossing over, is, and write it as a point, x was 3 and y was 3. And we're done. Okay, the last question I'll be doing, because it's getting late and we're running out of time, is this one here. A line segment has endpoints, and here are our 2 points. And first one step asks us, draw the line segment on a graph. And that's quite easy, just drawing these 2 points and joining them up. B, calculate the distance of the line segment, which is like the length. And C, calculate the midpoint of the line segment and show this on the graph. Okay, so that's pretty straightforward. Sorry, I forgot to pause it as I was drawing, so I didn't realize. Now, you can see I quickly drew, as best as I could, a graph. And now we're going to plot these 2 points. So I've got, when x is -8, y is -1, so there I am. And of course, when you draw a graph, you use a ruler and the proper scale, please. I just can't do it on the writing pad properly. And x is 2 and y is 0. So it's right there. So see, these 2 points are the end of our line segment. And if you're not sure what a segment is not a line, because a line is if I drew a line here, I'd use arrows saying the line never ends. A segment stops at 2 points. That's why it says draw the line segment. These are the 2 points where my line segment stops, and I've plotted those points. So my final step is to join those points. And I've drawn it, that's it. But remember, you use a ruler in a proper scale. Make your graph as accurate as possible. So that's our first step. So question A is done. Now question B asks us to calculate the distance of the line segment. And then C asks us to calculate the midpoint. Now I'm just going to explain the midpoint. The midpoint is the point that is exactly halfway between these 2 points. Okay, and remember, a point means a point on the graph. And I can estimate what this is. If I had drawn a proper scale, it would be more accurate. But looking at this, I could say perhaps my midpoint would be when x is -2 and y is negative 0.75 or something. But like I said, my graph is not accurate. But just as an estimate, I should be getting something around there. If I got if I calculated it and x was a +5, which is over here, I can see I've made a mistake. So just remember, when you find the midpoint, you can estimate where it is by looking at your own graph. All right, so we're going to calculate the distance of the line segment. And if you remember, calculating the distance of a line segment, we use our knowledge of rise and run between 2 points. So for me to get from this point to that point, I have to rise a certain amount and then run across. And I know it's messy, but we actually make a right angle triangle. So imagine that was nice and straight. And we can see that with this right angle triangle, the line segment, this line here, is actually the hypotenuse, okay, of a right angle triangle. So all I need is this length here, or distance, and that length here. And I can do that. That's just my rise and my run. Now, because I haven't been given a graph, I've got 2 points. I can easily find my rise and run using our knowledge of that the rise and run is the difference between 2 points. So y2 minus y1 over x2 minus x1. Now I can do it this way and do it step by step, find my, and then label it. That's my rise and my run. And then our next step is to use Pythagoras Theorem. And we know a right angle triangle to find the hypotenuse, C, which is our hypotenuse. So this length is C. C squared is equal to A squared plus B squared. Now I'm going to just change one more thing. See how we have that C squared? I can actually start the process of solving C by getting rid of that squared. To do that, I square root it and it cancels out, but I must square root everything on this side. So I'm left with C equals the square root of A squared plus B squared. And that's what I'd be left with. And the reason why I've done this is because in your textbook, these two processes are summarized in this one formula, and we can combine them to save us some time. If you want to do it step by step, find the rise and the run, and then put it in Pythagoras Theorem, and you still find the distance, and you can still do that. But in your book, we have this formula, and I guess it's important to understand how to use this. That's where we get that, instead of C now, we say distance, because we're finding C, but we call it the distance. And then, see how I started solving this? So a big square root, and then we have A squared plus B squared. So my A could be y2 minus y1. The textbook puts the x2 minus x1 first, but it does not matter at all, your choice, but I'll just go with the textbook so it looks familiar. So I have x2 minus x1, and please make sure you square this just like in our formula. A is x2 minus x1 squared. That will give us this length here, plus b squared, which b is y2 minus y1. When I put them in, I will find that point. Sorry, I will find that length, that distance. But please don't forget to square it, and there's a plus in the middle. And that's the formula we use. It's just combining Pythagoras' theorem and putting in your rise and your run. We haven't found the rise and run, which is why we have x2 minus x1 and plus y2 minus y1. Okay, I've just made some more space. Now I've put my points down here so I have more space on top, and I've labeled that's x1, y1, x2, y2. All I got to do now is put these numbers, substitute them into this equation, and we're done. So distance will equal the square root, so x2 minus x1, so they're still in brackets, so I've got 2 minus x1, which is -8. Please don't forget that squared, plus y2 minus y1. 0 minus minus 1 squared. Okay, and then we'll simplify this. So we have, I put like I was writing a question. So D equals the square root of 2. Now a positive and a positive make, negative make a positive. 2 plus 8 will give me 10 squared. Now it's so important to leave the brackets, because if that was a -10 and I'm squaring it, and you put it in your calculator without brackets, you would end up with a -10, and that's wrong. Just remember, no matter what you have, a negative or a positive, you will always end up with a positive under the square root. You cannot calculate anything with a negative under the square root. Just keep that in mind. That square will make any negative a positive. That's why you must use brackets. Plus, it becomes a positive, which is positive 1 squared. And then we're almost done. We have the square root of 10 squared. Well, that's 100. And then 1 squared is 1. So 100 plus 1. And my distance is square root of 101. And we're done. Now, if you look at the question, it didn't actually specify. It just asked us to calculate the distance. Sometimes the questions say leave it in exact form. And exact means if it's a surd, you just leave it as a surd. And if I have a look at my answer here, I have a surd. The square root of 101, I can't work it out. On my calculator, it gives me an endless decimal. So I'll leave it in exact form. If the question said approximately, you put it in your calculator, write the approximate symbol, and you just round it off to what the question asks you. But we can stop there because the question didn't specify. And now we'll find the midpoint. Now the midpoint, all we're doing is adding the x values together, adding the y values together, dividing them by 2, which is sort of like finding the average, and that's it, we found our point. So for the midpoint, we use a capital M, because a small m represents gradient, so a capital M represents the midpoint. And see how we got one, I'm going to use, it's 1 point, x value and your y value. But to find those values, I'm just going to label this. So I've got my x1 and y1 and x2 and y2. Because there is a formula, you don't have to write it because it's just adding the x values. But what you have is x1 plus x2, just adding them together. You don't have to have x2 first, doesn't make a difference. Over 2. And that's your x point when we put those values in. And of course, y1, which is negative, y1 plus y2 over 2. So we'll sub in those points. x1, now, if it's negative, you put in a negative. So x1 is negative 8 plus, and x2 is 2 over 2, or divided by 2. Well, it's a point, I guess. Oh, you can leave it out until later. And then y1, we've got negative 1 plus y2, which is 0, was it? Yep, 0 over 2. And now we simplify and we're done. But you must make sure you calculate what's on top first. Minus 8 plus 2, that leaves me with a negative 6 over 2. And minus 1 plus 1, that leaves me with a minus 1 over 2. So my y value is a negative half, or 0.5. My x value, well, 6 divided by 2 is 3, and it's a negative. So the final answer would be, our midpoint is when x is a negative 3 and y is a negative half. And the question did ask to show this on the graph. So all you got to do, remember, if you drew an accurate graph, you would have your axes and everything. And this is the point. When that point there is when x is negative 3 and y is a negative half. Okay? And you should also show the point of your the end of the segment. And that's it. I'll just put a bracket there, sorry. And just remember, that is not saying, I guess, halfway of this length. It's not saying that. It's saying it is halfway, but this thing here is the point on the graph. What is the point on the graph of halfway at this point here, which is our line segment? Okay, so hopefully that's helped, and you can see me in the morning if you have any more questions. Thank you.